Before we start this video, a large thank you to a name I unfortunately cannot pronounce. Thank you very much for the support, my friend Ruvinus, Mandolis, Lewis, and Future Z for their support on Patreon. I hope you guys enjoy the video. And, as always, an immense and massive thank you to Halo Burner and Ryan Bellin for their continued support to the channel this month on Patreon. I hope you guys enjoy the video. Hello everybody, so I am here with Diablo 2 open, and as you can see here, we kind of have a fixed camera. It's kind of pointed down towards our character, and wherever I point and click or hold and click, my character is moving. So this is the camera and movement setup we're going to replicate first, and afterwards I'll probably show some stuff kind of more similar to Grim Dawn or some other different kind of ARPGs. So I am in the project here now, and the first thing I'm going to do is look for my world scene, and I'm going to open that up, and then I'm just going to create a plane here so our character has something to stand on and walk on. I'm going to double click it to bring it back into view. Now I won't focus too much on the camera in this video, but just to show you how to quickly set up an isometric camera, reset your transform. Set the X rotation to 30, the Y rotation to 45, and the Z rotation stays on 0. Change your projection from perspective to orthographic, and I'll just show you how it changes the camera view by, if I put my plane into view here and change it, you can see it is very different. Now, what I'm going to do is put my position back to 0 on the Y, and you can set your near plane to a negative value when the projection is in the orthographic view. Set your size to whatever you want it. So 20, 10, 5 is just going to change how it looks. And I'll just show you. If I put my clipping plane near to minus whatever, you can see the plane fully comes into view here at like minus 50. And then if I were to go over here and I were to change the size, you can kind of bring it closer or further away. So just play around with how you want that to look, but I'll spend more time on that in the actual camera video. So now I'm just going to make an empty game object called the camera pivot, and I'm going to reset its transform. I'm going to copy the transform we just made for our camera object and paste that on the camera pivot object, and then make a child the camera of the camera pivot object here, and then reset my camera's transform and set the z-axis to -10. So in the future, when we move our camera, we're going to just move the camera pivot object, and the camera will stay exactly where it is right now at those values. Okay, so that does work for what we need for this video, because we just need to see this plane. I've set my size here to 5 so it zooms in a bit. And now if I go into the project and click start and load into my world, there we go. We have our man here standing on a plane. But obviously clicking it, nothing happens. So let's go over to our player prefab now. And we're going to add another component called the player locomotion manager. And if any of you guys are familiar with my tutorials before, you're going to know that the player manager is the, we'll call it like the brain. It houses all of the components of the character, and if you want to reference any of those other components, you go through the player manager. So the player locomotion manager is going to be the first component we create. In the future, we'll have things like player animation manager, etc. Now I'm going to make an empty game object. I'm going to call it the input manager. I'm going to add a script called the input manager. And some of you might be wondering, why don't you add this on the player? And the reason being is you might still want to access this if your player's game object is deactivated. So I always have the input manager as a separate object in the scene. Now delete the start and update functionality as is per tradition, dropping your namespace. And now go to your input actions. You should have a default one here, probably called something like this, input system actions. And I'm going to delete everything inside the player. So you can see we have action maps, player, and UI. I'm going to keep UI. I'm just going to delete everything inside player. And this is where we set up our player's inputs. So if I create a new action, I'm going to have it set to a button. And I'm going to call it left mouse, or we'll call it left click actually, because left click is going to do several things. Now we're going to set it up to the left mouse button, like so. And I'm going to tick keyboard and mouse. And we're going to cross this out and save it. And then there's a tick box up here called generate C# class. But first we're going to rename that to inputs. And then we're going to apply. And it should generate a script we can reference. Cool, it does. What happens if I rename it again? Does it rename the script? I'm just curious. I'm going to call it player controls actually, because that's what I call it in every series. And no, it does not. So let's delete this old script if you renamed it like me. But basically all that does is it generates a script that allows us to reference values that we actually have in that little object there. So we can now reference our left click. So I'm going to create a public static input manager instance on awake. If instance is null, instance equals this, otherwise destroy this game object. And now we can begin to set up references to whatever inputs we have set up on that little object there. So right now it's only left click. So first, let's go and make a private player controls, as in the player controls script. We'll call it player controls. And on enable, if player controls is null for some reason, we're just going to generate a new one. And obviously it's going to generate a script exactly like the script that's there. So any values that we have that were created through that little, I'm going to keep calling it input object, not sure what else to call it, is going to be on that script. So then we're going to say player controls.enable. Now on disable, we're just going to simply say player controls.disable. Okay, now on enable, we need to reference our left click. So first, let's come up here and make a header, not a help keyword, a header, my bad. I'm going to call this inputs. We'll keep it very general for now. And our first input is going to be a private bool left click. And we're going to initialize that at false. Whenever we click, we want to turn that to true, basically. So if we want to turn that to true when we click, over here on enable, I'm going to make a comment for mouse inputs. We're going to say player controls and then dot player. And our player controls, remember, is this. So just to go back and be very clear, player controls is this script, right? Now, if you open the action inputs, player is this action map. So player controls, player, and then we want to get the left click. So it's going to be player controls dot player, the action map, dot left click. That's the button we just made. And then we're going to say dot performed. So whenever it's actually firing, then we're going to say plus equals I is equal to or greater than a left click is equal to true. And all this sentence means is whenever we actually perform the left click, we're turning our left click boolean up here to true. So let's make a serializable field just so we can see that, because I want to show you, just really nail home the point. And whoops, this should be on enable, not on disable. That's my bad. So come up here and put that right here. There we go, like so. All right, now if I save that and I go into the project and I start the game, you can see there's a left click here. We can see it. Now if I click anywhere on the screen, you will see that this turns true. Cool, so now we have it set, so whenever we are clicking a mouse, we're going to change that boolean. Now, make a private void handle input actions. And this one is going to be a function we call an update that will handle and track all of our input actions. So in the future, that might be left click, right click, your F keys, if your WASD is set to anything, all that. This is going to be a master function that will contain all those functions that we call on each frame. So I'm going to make an update function like so, and I'm going to call that. Now we have our master function. We need our individual functions that are going to do things for each individual input. So our first one is just tracking what we do when we click the mouse on the left click action. So what does happen on the left click action? It's fun to think about that when we're making this. Obviously we want to move now, but other things happen when we're actually going to do a left click. And just for fun too, I'll put some pseudocode here just so you know that this other function will do other things like handle right click action, handle F key actions, and you can say whatever you want, what have you. I'll just put this here for now, etc. So under handle our left click action, if there's a monster, we attack it. We know it does that. If there's an interact, we'll interact with it. And if there's nothing else, then we're going to move. So I'll just say, if there's nothing, attempt to move to the position. Now, if we jump into Diablo real quick, let's just take a look at that. So if I attack a fallen, I attack them, right? You can see my player rush to attack. If I click the well, I drink from it. And if I click the map, then I move around. So that's what we want to replicate, but for right now, all we're going to do is look for this moving action. But we can keep the rest here as pseudocode. So the first thing we want to do is, after we left click, we want to disable left click immediately. Otherwise, we don't want to have left click permanently left on and running this action every frame. So let's make another serial or header up here. Sorry, not a help field. I don't know why I keep doing that. We'll call it our movement position because I just want to track this. Let's make a serializable field vector 3 and call it movement position. Next, let's add don't destroy on load after we do our singleton check if we're not destroying the game object. And then down here within left click, let's open up some curly brackets and let's actually write some logic. So I want to really I want this to be visual too. And a mistake I made with Elden Ring is, well, I think I explained things adequately, but I want to really have you see it. So we're gonna try to make these things visible in the inspector in the game as well, and try to visualize a lot more of this stuff. So let's make a raycast. And we're going to say it's equal to the camera main.screenPointArray. What does that mean? Well, I'll get to that. First, let's reference our mouse, and that's reference to the new input system, .current.position.readValue. And all this means is we're casting a raycast from wherever our mouse is on the camera. So right now, if you can see my mouse, pretend there's like an invisible ray or a laser shooting from that, and it's going to go to a place in the game's worldview in respect to where it is. And we're going to show a visualization of that really soon, so we're really going to nail it home. And we're going to say if the raycast, and we're going to pass the ray out, and we're going to say raycast hit, and then we're going to say hit, and then we're going to say math f.infinity for the length. So if it hits anything, we're not going to use a layer mask right now. We're just going to keep it checking for everything, but we'll make a layer mask in the future. And then we're going to say if it does hit something, we're going to say our movement position is equal to whatever it hit by saying hit.point. So we're going to shoot a raycast out from wherever our mouse is on the screen. If it hits something, we're going to store what it hit in our movement position as the hit point. Okay? Now let's go to onDraw gizmos, and I'm going to make it draw a red sphere wherever it hit. So we're going to do that by saying if our movement position is equal to vector 3.0, because that's what initializes that. So basically, if we've never clicked anything, then simply return. Well, we don't need to draw anything. So if we haven't clicked anywhere yet, the position is still 0, 0, 0, do nothing, right? Then we're going to say gizmos.color is equal to color.red. And then we're going to say gizmos.drawSphere, sphere. And we'll say, what am I going to say here? Well, obviously we're going to pass the movement positions where we just clicked, and then we're going to say 0.2f for the radius. Now, magic numbers are generally bad, but I'm going to make a comment here just to show that 0.2 is the radius of the sphere. But if you want to make a variable for the debug sphere radius, go for it. So I'm going to save that. I'm going to go into the project here right now, and I'm going to go into the game, and wherever I click, you might not see anything. Make sure you click gizmos up here in game view, and then you can see, boom, wherever I click, it should draw a sphere. So now we know where we've clicked, and that's a good just visual indicator. I'm going to turn off gizmos until I go back in the scene. Now, if I go to my player prefab, I'm going to make a NavMesh agent. And some of you might be wondering right now, why are you making a NavMesh agent as a child object? I promise it will make sense, if not in this video, in the next one I explain it. Because generally speaking, a lot of people will just make the NavMesh their main object, and then they can do their movement from there. But I have a reason for doing this. So let's make a NavMesh agent variable on our player manager. Alternatively, you can put it on your player locomotion manager if you want, but I like putting all components on this one manager because that's where I reference everything. Now, you're going to need to say using UnityEngine.ai up top. NavMesh agent is equal to get component in children NavMesh agent because it sits on a child game object under our main game object that houses our player manager. So I am going to hide this in Inspector and make it public because I don't need to see it, but also I need to reference it from other scripts. Likewise, I'm going to come over here on my player locomotion manager, and I'm going to make a reference to my player manager soon, but first I'll make a function called move player to position, and I'll make this pass a vector 3 new position. So let's make a player manager variable, player, and on awake, I'm going to say player is equal to get component player manager because it sits in the same game object as this. All right, so I'm going to say here player dot navmesh agent dot set destination, and we're going to pass our new position like so. Now we're going to call this whenever we click and get our world position from clicking. So the first thing we're going to do is make a new hide in inspector public player locomotion manager variable on our player manager. I'm going to call it player locomotion manager, and on awake I'm going to get that, but the difference is I'm not going to use get component in children. I'm going to use get component. Now, how do we reference this player on our input manager? Well, first, let's make it derive from a network behavior. And this is a netcode thing that's basically going to make this able to use some of the network calls. So we're going to call override on network spawn, and this is called as soon as the game object is spawned on the network. So let's go over to the player, or rather the input manager. Maybe I should have called it player input manager. Anyway, let's make a public player manager variable, and you can call this local player if you want, but I'm just going to call it player. Basically, this is your player that you own, and we want to fill this variable when your player object is spawned. Now, the easiest way to do this is to go over on network spawn and say if is owner, and that means if you own this object, and this will only be the case if it is your player object. We're going to say input manager.instance.player equals this. Now, what do I mean by if you own the object? Well, obviously, if I join your game, there's another player object in the game, right? But that's not your object. Yours is the one that's spawned and set to your player object. So when this object is spawned, if it is our player and not another player spawning the world, assign this player object to the input manager. All right, cool. So now that we have that, now we can influence this player via things we do in the input manager. So down here on handle left click action, what we're going to do is every time we have a movement position, we're going to say if the player is null for a simply return. Otherwise, we are going to move this player. Then we're going to say player locomotion manager, move to position and pass the movement position. Okay, let's save that and take a look what happens. So if I go in the world scene here and save that, we're going to go over and create an empty object, and I'm going to call this NavMesh. I'm going to add a component to that and reset its transform called NavMesh surface, and I'm going to bake this. And what you'll see is it's going to turn like this blue color, and we need this to move around in the NavMesh. This is just all areas we are allowed to traverse as the NavMesh agent. So whatever you're doing, you can change it to if you want to use the render meshes or the physical colliders. And I'm going to hop back in here in the input manager, and I'm going to call start. And on start, I'm going to set this game object to active false. Now, why am I doing that? Well, I don't want to run these inputs, like, for example, clicking to move when we're on the title screen. So I'm going to call scene manager right before that, dot active scene change, plus equal, and here it says press tab. Go ahead and do that, and then you can insert this function. And I'm going to call out, or rather change the name on scene change. And for anyone wondering, this first thing here is the old scene, and the second argument is the new scene that we're going to. They don't really matter for what we're going to write, but those calls are useful if you want to use this function for anything else. What I'm going to do is, and I'm going to go into the game here and go to my world save game manager. I'm going to make another serializable field for menu scene index. I'm going to equalize or initialize that as 0 because that's what it is. And we're going to have to set that to public. But just to show you, if I go down here in the build profiles, you can see here our menu scene is at index 0, just to confirm. Now I'm going to come back here in the input manager and say scene active scene is equal to scene manager dot get active scene. And then we're going to say if active scene dot build index is equal to our world save game manager dot instance, and then we could say menu scene. Oh, but we forgot to make it public. And somebody in the comments is screaming at me right now, Seb, use a getter and setter so you can't accidentally change that. And I'm going to say that that's valid. I'm not going to though, but that's completely valid. And if you're working with many people or you think there's a chance of overriding your code like that, you should definitely use a getter and setter. So if the menu scene index is the menu, then we're going to set the game object to false. Otherwise, we're going to set it to true. Now, what does this mean? So this function is called every time we change a scene now. We've subscribed to that on scene change event. What we're going to do is disable the input manager if the scene is equal to the menu scene. Otherwise, I'm going to assume any other scene in our game is going to be a world scene. So we're going to enable that. That will basically allow us to move around our character. Now, you might be saying, well, if this is disabled when we start the game, is our player going to be grabbed? And the answer to that is yes, it's going to be grabbed despite the game object being disabled. Watch, it's at 0. If I start the game, the player is spawned, it inserts itself. So you have to disable it after the singleton is set, and then we're good to go. Now, if I come in here like so, and I put the scene view by side and activate gizmos, let's make sure gizmos is on in your scene view as well, by the way, so you can see this, and highlight your NavMesh agent. So watch what happens now. If I click anywhere on the NavMesh, you can see the agent is actually moving there. Now, obviously, our player is moving there because we're not following the agent. So in the next video, what we're going to do is we're going to get this player to follow the agent, and we're also going to talk about why I chose to make the agent as a child object. Now, you could just use the transform and the rotation of the agent and do it that way. And this is the point in the video where I'm going to encourage you actually, before we come back, set it up so our player object is moving with that NavMesh agent somehow. If you want to change it and you want to change the position so that the NavMesh agent is on the parent object, that's cool. But in some way, shape, or form, I want you to make it so that before you start the next video, that player object is going to move with that NavMesh agent. If you want a hint at how I'm going to do it, we're going to use a hybrid system that will involve a character controller as well. And we're doing this so we can use the movement from our animations. That way there's no foot sliding. Basically, I'm going to make it so although we are navigating with a NavMesh agent, we are actually going to utilize the movement of whatever animations we're going to use. So your player's feet match exactly as those animations are. That will mean in the future, if you want to adjust movement speed, we're going to adjust animation speed. But definitely do it anyway. It'll be a great learning experience. And obviously there's more than one way to do this. There are pros and cons to every approach. So definitely do it and let me know how you're going to do it and how you did it in the comments. We're pretty much at the allotted time of this video, so that will be all for me today. I hope you are enjoying the series. Thank you to the people who take the time to leave a like and comment to help the video circulate. It is appreciated so much. Thank you to my patrons for making series like this possible. I hope you guys have a very lovely weekend. I will see you all in the next one. I'll see you guys in the next one.